in listen-only mode.
Hello everyone, this is Leslie at VCGI, and sorry we're a couple minutes late getting started. We had a few technical problems. So we are going to start with John Waterman doing this webinar today in just a minute, but I'm going to start out with a very brief intro for anybody that isn't familiar with using GoToWebinar or online webinars in general. So this slide that you see in front of you is pointing out just the way that the panel on the right works. So you'll notice that you have a panel and it has this orange button with an arrow in it, and if you just click on that, there we go. It should open up your panel. You can also close your panel by clicking on that. So if you want to get the panel out of the way, you click on that same orange button. I also want to point out the fact that if anybody's having audio, oops, getting music from somebody, oops, sorry about that. That if anybody's having audio issues, that you can change your audio options or access your audio options like the pin code in the audio part of the panel. So again, to open it up, you just click on the little plus sign, it'll open up and you'll see the pin, the number to call, and your various options in there. And notice that if you're using a mic and speakers, you need to change to that. So you need to have that appropriately set. The other thing I want to point out is this little hand-raising button right here. Looks like a sort of an orange hand with a green arrow on it. And just to make sure that you can all actually hear me, it's kind of reassuring to me because I have you all muted. Could you just click on that button, and what will happen is on my panel, I'll get to see all the little hands next to your names. And that way I know you can hear me and that you can click on that and it's working. That's great. Okay, thank you. Somebody has a question. All right, the other thing I wanted to point out is the fact that, oops, at the VCGI website, in the Community Resources section, if you go to the Events page and then just scroll down a little bit, you'll see the Event Archive. And if you click on that link, that is where I post the recorded webinar. So if anybody was wondering whether this is going to be recorded, it is being recorded, and I post the webinars sometime in the next few days or week right on this list. And the newer webinars will be up at the top, so you can see that the two that we've done so far this fall are posted there. And I think that's all I have to say. So John, are you ready? Nope, you might be having technical problems again.
Yeah, I'm ready, Leslie, thanks.
There you are. Okay, great. I
am on my, go ahead.
I'll switch over to you as presenter if you're ready, and then we can get going.
Okay, sounds good.
Oh.
Does that look good?
Yes, I can see you.
Okay, is Alex Philp on the line too?
Yes, he is. I have, he sent me a message that says he's here.
Okay, so can we both talk at the same time?
No, because he's not a presenter. Let me see if I can promote him. Hold on just a sec. Okay, Alex should be able to talk now too if he's connected.
Yes, can you hear me?
Yes, we can.
Great.
And can you hear me?
Yep.
Okay.
Yeah.
Oh, you can. Great. Now the only trick, Leslie, is to give me
visual.
back the presenter for the desktop. Great.
Okay.
Okay. Sorry, Leslie,
No
but
problem.
I think we're good.
Okay, great. Thank you.
Okay. Leveraging the cloud for your GIS. And thanks, Leslie, for offering the webinar. And my name is John Waterman. I'm with GCS Research, and we also have Alex Philp on the line from GCS Research. And And Alex, would you like to give an introduction to GCS?
Sure, I'll keep this really brief. Can everybody hear me okay, I hope? First of all, it's a pleasure being here today. Thank you very much, Leslie, for this opportunity to discuss GIS in the cloud and what that means to organizations today as we rapidly approach 2013. As John mentioned, John and I both work for a company called GCS Research. I started the company 10 years ago. We're headquartered in Missoula, Montana, and it was an outgrowth of work that I and others did at the University of Montana working in advanced GIS and the convergence of geographic information systems and, guess what, the Internet. It stands for Geographic Communication Systems, and over the years we built a practice that services a variety of customers, both locally, regionally, nationally, and now internationally. We provide geospatial IT solutions ranging from complex systems to very simple systems, and have also done a lot of work in the industry over the last 10 years in advanced R&D. Some of these have involved things like building early versions of Google Street View, our work in video and video processing and geo-video, the mobile space, understanding mobile applications, and now increasingly understanding the cloud infrastructure and what that means. And I'm here to support John and co-present today and expand on some ideas and some thoughts that we have that we want to share with the community, and you know, some lessons learned, some things that we're looking at, and where we see this going. So we see this as a good opportunity, and again, very much appreciate it. Thank you.
Thank you.
Okay, so I'm going to jump straight into the presentation. What are people looking for in the cloud? I think the first thing people are looking for is really cost savings. You know, a traditional model is the license model. People don't want to pay for licensing anymore. Governments, organizations, they really just want to pay for what they use. So a use model. You know, if you want a cup of coffee, you go pay for it, but you don't want to pay for it if you're not going to drink it. You know, some other aspects of cloud I think that people are looking for, maybe more technical folks, the new agile features, and then optimization for higher quality, backup and recovery, better performance. Those are more of the techie people that are looking for that. I think the bigger picture really is the cost savings that the cloud can give you. Here's a pretty long definition of the cloud. It's cloud computing. You know, it's computers on the internet, connected to networks, serving data. You know, but really what makes it the cloud and what makes it not the cloud. These are essential characteristics that makes a system the cloud. So if you know you're working in the cloud, of course you have access to the internet. You have this thing called resource pooling. So the servers, lots of servers out there working together. You have this word called elasticity, which goes one-on-one with the cloud, which means that the servers and all the resources are expanding and contracting based on the load, based on your users who are accessing your application in the cloud. And then measured service. Everything needs to be measured in the cloud. Usage metering, you know, this is really important because the cost model is based on usage. And so both you, the customer, and the provider need to know what's happening in the cloud based on your applications. So just to expand on some of those essential characteristics, I mentioned resource allocation, so dynamic resource allocation. This could be a picture of your current organization where you have these stovepipes and you have these servers in each of your parts of your organization. And it's not real easy to all of a sudden go from here to here and shift those resources when you're hosting your own servers. In the cloud, all of this is automated. These resources shift automatically, and each of these stacks you see here could have one of your applications, could have somebody else's application. nobody knows. It's all put together to be optimized and work together. It's a characteristic of the cloud. Another characteristic is resource pooling and geographically. So this is for failover. So you can purchase in the cloud to put your applications in certain farms throughout the world. You can put one here on Amazon. You can put one over here, and then these are load balanced. And if one cloud goes down, the other one picks up. And if we read the news, Amazon does have issues sometimes. If you have a mission-critical operation, what I think is pretty cool, or I see people that are deploying in the several clouds. They may have a primary cloud as Amazon, and then they decide to also deploy in the Windows cloud, the IBM cloud, and these farms all over the world. And the reason why that works is the model is you only pay for what you use. And so it can be very cost-effective and allow you to have a mission-critical operation very cost-effective with redundancy.
John, can I jump in there real quick on that one? One thing you'll start to see, folks, in 2013 in particular, and it's not completely new, is you'll hear a lot of discussion about hybrid architectures and hybrid cloud infrastructure. So as John was pointing out earlier, what's becoming increasingly difficult for organizations to afford is the rapidly depreciating infrastructure, the server architecture that we all know is becoming mission critical to build and deploy and serve our customers, our constituencies, our publics, whatever that business process is. And so as John mentioned, not only are we starting to see a lot of standard IT 3959 deployment scenarios, but we're starting to, people are mixing and choosing different services in different places against different data sets, against different requirements, from low-level data storage and data hosting all the way up to supercomputing and high-performance computing architectures, which we'll talk about a little bit more in the future. So pay attention to hybrid as a word qualifying the different types of cloud architectures that are being offered by some of the most major players in the IT space there is, the IBMs, the Amazons, the Googles, the Microsofts, as well as even other organizations are getting into this. The hard part now, the cheap part isn't, or it's not the servers anymore that are prohibiting us. It's the transaction fees where the money is being made. Thanks, John.
Okay, thanks. Another word, elasticity, cloud rapid elasticity. This just means behind the scenes there's a lot of scaling going on based on demand, and this is spread across servers that are hosting, lots of data from all different customers, and it's all done automatically. But you also, as a cloud user, a cloud customer, can have your cloud administrator go in and tweak the dials, the knobs, the switches to maximize for your organization based on your cost model. And so it all goes back to pay as you use, and really the sky's the limit on how you can scale up and down, and with unlimited data storage, etc. So with the cloud, you also have this self-service. So you have an administrative console, and I think what's unique about that is you have this new job role, the cloud administrator, that logs in remotely and administers the cloud without having to interact with any of the cloud providers. So no need to interact with humans on the cloud provider side. Basically, somebody in your organization would probably log on and do what they need. So getting into the service models, and I'm sure a lot of you have heard at least some of these service models, and there's a ton more. These are the three core, so software as a service, platform as a service, and infrastructure as a service. And I think the best way to really understand these are just examples. And most people on the phone are probably familiar with the ESRI technology stack, and they have offerings throughout this whole, all three of these service models. So the one that we're most familiar with, I think, is software as a service, and that's ArcGIS Online. If you've seen demonstrations or used ArcGIS Online where you can go in, author a map, you can publish it. You don't have to write any code. You can create a web app, but ESRI has provided that software for you that you can get on and use their software on their cloud infrastructure. Platform as a service is, if you look at ESRI technology, these are these APIs that they host on in their cloud that you can use. So JavaScript APIs, the Flex, the Silverlight, but also, you know, Google API, the Microsoft mapping thing. So ArcGIS Online is also something, or ArcGIS Online Web Services, so they have web services that application developers can hook into. That's considered platform as a service. And then infrastructure as a service is really what a lot of people think about when they use the cloud. The other two are, you know, could be in the cloud, cannot be in the cloud. But infrastructure as a service is definitely you're in the cloud. You get your own server in the cloud. You can quote unquote provision it. So you'll hear provisioning quite a bit as a keyword. So you can spin up, provision these virtual servers in the cloud and install whatever you want on them. And that's infrastructure as a service.
And you're also, on just one point on the infrastructure as a service, what you'll see a lot too, and this is becoming a really important space, is a lot of companies, in addition to the majors that have the wherewithal to host the data centers and the data farms and to provide the redundancy, is a lot of software is being written right now to help in the process of provisioning and staging and deployment and management. So since so much this is around metering and controlling costs and looking at usage and understanding those historical averages and surges in capacity and those failovers and those scale-ups, you're starting to see software being written and already being written by both the majors and other companies to help manage that infrastructure. Again, there's significant cost savings for folks, you know, that you don't have to basically maintain your own servers anymore, but you're really looking to leverage massive investments on the part of these major players.
And this is a Montana Site Selector. Alex, do you want to talk about that?
Right. So as John mentioned, one of the ways you can start to get a sense of software as a service, platform as a service, and also infrastructure as a service as different dimensions of the cloud is to look in some examples. These are things that we have done at GCS Research over time. This one is called Montana Site Selector, and this is really infrastructure as a service combined with application as a service. This is a brand new cloud-based application built for the state of Montana by us for the state of Montana, specifically to support economic development activity as it relates to site selection. So for those of you that aren't familiar with that business process, a lot of people are looking to build a business, grow a business, recruit, retain, renew a business, and tools like this are built to provide a connection between someone seeking to do a siting and the people that are offering the property. So in this case, what we did, because we knew we were going to have a tremendous amount of users, we needed to have a robust infrastructure upon which to deploy the application. We built the application, we wrote the code, it's delivered in the web, on a tablet, and now on a phone, but we worked with one of our providers, one of our partners, Microsoft, and we leveraged Azure, which is their cloud infrastructure. And essentially, in July, we deployed the application. So when a client, when a customer, when a user goes to the web, they get the functionality. What's going on behind the scenes is data and data services are being hosted on Microsoft. Other services are being hosted at another data center where ArcGIS server lives. And at the end of the day, you have a seamless experience coming together at the application level. So application code and infrastructure both are being delivered as services ultimately to the end customer. And that model could be scaled not only statewide, we're now pushing it regionally, nationally, et cetera, et cetera. It takes a lot of the costs out of building a robust application out of the equation, and again relying on these other systems. And so that is a real-world example. if anybody's interested in more technical detail about that, how it occurs, we'd be more than happy to share it. And again, it is a statewide initiative, an enterprise initiative. A few years ago, this would have often been described as a federated solution, but now that we have the word cloud in terms of a new nomenclature, you're hearing less and less about federated architectures and more about, again, infrastructure as a service or cloud applications. So that's a little bit about Montana Site Selector.
Okay. Thanks, Alex. So those are the three main service models, and there are a ton more, and people make up new ones every day. And really what a cloud service model simply means is it's the type of service that's provided to customers by that model. And so you see things as storage as a service, security as a service, data as a service, even GIS as a service. We've been involved in a project which has a service model called modeling as a service, and it's called Ideas, and we created it for an organization called the SI organization. Alex, you want to say a couple things about Ideas?
Sure. It dawned on a couple of us, as well as our client, the SI, and they're a spin out of Lockheed Martin. You can Google them and find out what they're doing. But it dawned on us that one of the most fascinating and powerful areas of geospatial analytics is how we use models to better understand our world and predict things. So you might hear about big data and big data analytics and some of those buzzwords. And so what we designed is an architecture to move to the notion of modeling as a service so that you could combine the right data with the right model at the right time as a series of services on demand, paying as you go, for computationally intensive exercises in hydrological modeling, wind forecasting, fire modeling, soil monitoring, and really sort of taking the value and the power of modeling. Have any of you ever dealt with the USGS or NASA or any of the other major dominant public sector modeling agencies that build robust models, you'll realize that one of the hard part is discovery, and the second is deployability and accessibility, and how to actually create a runtime environment for our models that are out there that we would like to use and to determine and benefit from. So we've been shifting and pushing this whole notion of modeling as a service around a consortium of companies that are highlighted in that slide. This slide is available for anybody that wants to see it, and we've been building that. So you go online, you go through a process of discovery, you define an area of the Earth, you look at which model is appropriate for what you're trying to conduct, you're able to determine the metadata and the provenance of the model, you auto-populate that with data as services, and ultimately you run the whole analytic online, on demand, against a very, very rich, robust back-end architecture that can scale to the kind of volumetrics we're dealing with in some of these instances. The output is delivered, the answers are acquired, and that can become an iterative process and really, really can be quite exciting when you open up and start to open up the very, very rich repositories that are out there that are available for modeling and simulation, and again gets us into better forecasting, better predictive analytics, and taking GIS not from where we are today, but where we are. So that's the notion of modeling as a service, and as John said, people are being very inventive right now in the space. They're coming up with all sorts of new ideas of how to deliver services, and things that we would traditionally have clustered around our own infrastructure or our own organizations are now available literally through our networked architectures.
Yeah, I think another thing that's cool about Ideas is for a cloud concept is actually pushing the model up close to the data center, so running it right next to the data opposed to downloading the data, which currently people do. And so pushing the model to the different data centers around the world, getting the results and combining them out in the cloud and delivering those to the customers.
That's a very good point.
Another thing that goes hand in hand is cloud and supercomputing. So doing complex analysis on supercomputers and delivering the results rapidly to customers. Alex, do you want to talk anything about extra
Sure.
fan views?
So, yeah, exactly. So actually, as we were just showing you modeling as a service, or MaaS, the early attempts at some of that was done in cooperation with an organization that was funded in part by the state of Montana, IBM Corporation, and a private organization known as the Rocky Mountain Supercomputing Centers. So the idea of bringing supercomputing and making that available as an on-demand cloud offering, one of the first of its kind in the world. And one of the problems that's really important to us out here in the Northern Rockies is this whole idea of fire prediction, the idea of fire rate of spread. And what you're seeing on your screen, hopefully you're seeing, is an actual run of what's called the fire behavior simulation analysis. So what we did in this case is we loaded up a ton of data on demand, the necessary data to feed these fire rate spread models. So this idea of what would happen to a fire on day 1, day 2, day 3, day 4. On the bottom of your screen, you should see the progression by days over time. And what we're doing is we're looking at predicting the rate of spread based on one of the dominant factors, and that's wind speed against a forest structure. So on the left-hand side, you have a forest that essentially has had no thinning, no fuel reduction, and that's the input to the model. It says we have a very, very thick forest, a lot of dead and down, and that represents a certain fuel type. On the right-hand side is after we've gone in and logged an area, we've done a silvicultural treatment, we've thinned out the forest, trying to restore it to some natural range of variability. And instead of having to do this painfully, running one scenario after another, we loaded all this onto a high-performance computing cloud architecture. And instead of having our computers crash, running this simulation 3 to 4 days, running these models, we were able to do all this in real time and then deliver this as a web app. So clients can come, customers can come, people, the general public, they can come and they can click on different areas on the map and essentially start their own fires and basically run these simulations, control some of those parameters. Now, as this gets more and more prolific and you see more of this occurring in the market, you'll see more and more modeling factors or modeling attributes being exposed, so that instead of having to sit there and have a PhD in modeling and all these computers and people that are loading all this, we see more opportunity to expose this kind of functionality, again, in thick clients, thin clients, the tablet applications, reaching back to an architecture that has the computational power to do this. In this case, we're accessing over 1,500 cores, running a couple terabytes of data, and doing it all in network real time. So there isn't any slowdown in the outcome and the attributes. John built the web interface. We also contributed as a team member to the back end, and again, this is still up and live and running as a demonstration of capability, because at the end of the day, it proved to the Forest Service, it proved to the state land management agencies and others that this capability was there. A little bit ahead of its time, there's no doubt about it, but the point is this is not vaporware. It was real, it was done, and it was done in a fairly collaborative way with a lot of different actors that all contributed different pieces of the puzzle to achieve the notion of the visualization and the analytical tools against the modeling as a service. Again, this whole thing is known as LandView, and it was done, we put it all together in about 3.5 weeks. Once the general concept was there and the funding was there. Again, just to give you some ideas of things that can occur.
Okay, thanks, Alex.
Yep.
Okay, so cloud pricing, talking about the model, a use model versus license model, where people want a use model, so that's only pay for what you use. Out on the internet, Amazon has been the lead with cloud computing for some time, and they have pricing models, these links you can go to and see actually how this works. And at the top here, the Amazon, for their public cloud, they make it so easy that you can click on that link, enter your credit card, and you can get working in the cloud in 5 minutes for free, and they give you 750 hours, et cetera, gigabytes. But you also have the pricing per hour, and you can see, you can choose the different data centers and installations that they have around the world. Some places have different offerings than other places, but this is kind of how it works. There's also a link that Amazon has for government too, so you can read a little bit about what they do for the government pricing.
Mm-hmm.
And I get more into Amazon and other cloud offerings in a little bit, but first, security in the cloud, traditional versus cloud model. You know, traditional security where you have your stovepipe in your organization, really, I see a lot of organizations, it's not really working anymore because executives are demanding to use their location-based devices. Checking in your devices at the door as you walk into your organization may not fly in the near future. These devices are just so much in demand. And traditional security models really have a hard time. And so that's one reason why people are moving to the cloud. You know, some concerns about security in the cloud are data storage, transfer, personnel, people. Who do you really secure things from? It's people. Not only people on the outside, but also people maybe on the inside of your organization. So I believe many of these concerns are mitigated through the cloud. Some of these advantages in the cloud are disinterested third parties managing data. So there's no local knowledge of the data. That slide I showed you before where you have all those disk arrays. I mean, there's so much data running into the cloud from all different areas that it's very difficult for somebody to understand what it is, let alone be interested in it. Pervasive automation. Everything is so automated. There's fewer humans. So there's less mistakes, but also less eyes, less interested eyes looking at your data. You know, the federal government is driving compliance certificates. This is pretty big. So there's a lot of money in the big players getting these cloud infrastructures certified. No need to maintain your security technologies, your local knowledge about the security technologies. I think one thing, though, that you do need to pay attention to, especially in GIS, is we have large data sets, and somehow you're going to need to get your data into the cloud, especially if it's like most people, it changes quite a bit. And so that's always a concern if you're moving information across the internet to make sure. Luckily, there's ways to do it, but it is definitely something to pay attention to. And then also, if you develop your own applications, front-end applications, you're definitely still always going to be responsible for your security, your authentication. So what I mentioned on the previous slide, the federal government is really driving these private cloud offerings, and there's programs out there that have been around for a couple of years that are driving these programs. So virtualization in the cloud, huge advantage. I know a lot of people are using virtualization locally. It's kind of the same concept, but you can do a lot. And how does virtualization change your GIS workflow? Today, the way you work, if you're an analyst or what have you in GIS, how would your work change if you could automatically just spin up a new version, a new operating system with ArcMap or ArcGIS Server, or probably more importantly, your ArcSDE or your enterprise geodatabase or your file-based data? You can easily create these different environments for testing, for development, for experimenting, for doing data visualizations and management. And one thing that a lot of people are going through right now is migration. If you're an ESRI ArcGIS Server user, 10.0 to 10.1 it's a paradigm shift. It's a huge level of effort for some people that have custom applications. One way to do that is through virtualization, and then slowly migrate over. So how does that change your GIS workflow? I think it's an interesting discussion to think about. Another biggie for GIS is storage in the cloud is infinite. So how would that change your GIS workflow? So for your GIS, what's the common GIS deployment that we see? I think people may be surprised, or most people are still going to need your on-premise system. If you're a shop that does editing, maintains GIS data sets, if it's streets or utilities or parcels, you're still going to need some way to edit those locally. Well, right now is what I see people doing it is they keep their on-premise environment, their on-premise ArcSD SQL Server instances, and then what they do is they use the cloud for publishing. So maybe ArcGIS Online or an instance of Amazon or IBM Cloud or what have you, and they will push their data up to the cloud if it's daily replication or weekly, and that's how they serve their customers, is through the cloud. And then internally, they still pay for their licenses to maintain their ArcSD on-premise. And just another thought on redundancy in the cloud is saving money. I've seen organizations that are getting rid of their failover systems, so tons of money being spent on servers that are just never used. And then on top of that, personnel to maintain that and knowledge to maintain all of it. It's huge. So what some people are doing are keeping their on-premise systems, but getting rid of their failover systems and putting those into the cloud. And then as the use model is, you only pay for what you use. That could be huge cost savings in the long term. So here's the job role, is the cloud information officer or even the cloud administrator. You're going to start seeing these folks or these job roles in organizations. If you haven't already, definitely requires new skills. For the administrator, you're not only a systems administrator, but you're going to have to become somewhat of a developer in the sense that a lot of this stuff is automated, a lot of this stuff is scripting. And Alex, were you going to say anything about this?
Yeah, I was just going to say that if you look at a lot of private sector organizations, and again, it's hard to know who exactly is on this call. Maybe we'll get some questions on this in a minute. But again, I think I'm seeing a transformation on what traditionally has been an IT-driven business process or strategic thought is really escalating up into the executive role. So the cloud information officer, not to be confused with the chief information officer, is really helping organizations take advantage of very, very cost-effective systems and architectures that some of which we've talked about. And then, as John mentioned, that really ends up then being an administrative function combined with the GIS staff. So I think there's a tremendous opportunity right now for your GIS professional at various levels to embrace, understand, and be part of helping strategize on the migration to a variety of cloud offerings to meet a variety of business processes and business applications. And I think you'll see more of this in the coming months and year. And it's really important if an organization doesn't have someone identified, and I don't think, it's not all about the CIO title, but it is about having somebody having that responsibility and owning this stuff, because it's not, you have to be aware of pricing, you got to be aware of your scaling, you've got to be aware of what applications you're building and deploying.
Okay, so Amazon Web Services, they've really been the pioneers with infrastructure as a service, and the reason why is they really created an IT consumer marketplace by making it easy. Like I showed you on their web page, you can it tells you, click on it, create a user, enter your credit card, you're up and running very quickly. You can start installing your COP software and start rolling. So ESRI started working with Amazon early on, and so Amazon is the only ESRI certified public cloud for their server technologies. And you can see that with the work that ESRI has done with Amazon. There's this thing called Amazon Machine Images. That's what they call these pre-configured virtual servers that you can spin up or provision on the fly. So ESRI has certified, preloaded their ESRI ArcGIS server software, their ArcSDE software, preloaded it, and then certified it to make sure it works correctly. They also have new Amazon Machine Images, AMIs for 10.1 for a couple different operating systems, as you can see. You know, from what I can tell, 10.1 was definitely re-architectured really for the cloud, and you can see that in these AMIs. So what do you do as a customer? What you do is you would spin up, provision one of these AMIs, maybe for ESRI that already has our GIS server installed on it, and then you would put your own custom applications, your own COTS software on it, data, and then set up your web applications, what have you. And then you would have your own custom AMI, which you can scale and provision and run in the cloud, basically. You know, if you go with Microsoft, currently I believe if you are in the Microsoft, IBM, some of these other clouds, basically same kind of concept, but you're going to be installing ArcGIS Server yourself, and which is not a big deal. But you start basically at the OS level. And ESRI has some great help online, which explains a lot of more detail about the Amazon Web Services and what that offering is. So there's a link. Other clouds that are out there, I already mentioned, you know, VMware, IBM. This link at the bottom, if you can read that, it's kind of long, but it's a very good blog where somebody has gone in and installed ArcGIS Server, and it walks you through installing ArcGIS Server and creating a map service in the IBM Smart Cloud. So that's a pretty neat resource, I think. Okay, getting to the cloud, you know, for your organization, you know, typically you would contact a cloud provider or a consultant that could help facilitate you getting to the cloud, but there may be some things you want to try and figure out before you get to that step. And here are some things I believe that are helpful for that initial conversation. You know, start to think about the scope, forecasting cost. Well, first of all, for yourself, you're going to ask, you know, how do you scope, forecast costs, and size systems based on your own usage and performance? So you may want to get with some of your technical staff and see if you can get your heads around your operational requirements. You know, how many number of users use your system at peak hours? What bandwidth do they use? What storage requirements? What length of time expected to be online? These are all things that your IT staff probably already have their head around somewhat, but getting this together before you initiate contacting somebody to talk about the cloud. There's also a couple acronyms that are used in the cloud quite frequently. So mean time between failures, mean time to repair. These are all acronyms that kind of you need to figure out what your, you know, for your organization, what you can handle. Alex, did you want to mention anything on this?
Yeah, I was just going to say, John, on your bottom point, and for those of you contemplating any of this, again, I'm looking forward to the Q&A here, but we recommend and have shown some examples, and lots of people are doing things where, you know, don't try to boil the ocean, quote unquote, when it comes to a cloud strategy and deployment in the cloud. You know, and all things, whether it's a private sector organization or a public sector organization, there's got to be some geospatial business process, some geo process. Some are very simple, some are very complicated. That you know, is meaningful. You're defining. I would add to this list, you know, looking at the notion of ROI, return on investment, and total cost of ownership. So TCO and ROI would be some other things to look at. And you can really start to look at the benefits and the costs of this migration. But pick a pilot project. Pick something that is an initiative. It might be an expansion of a public service utility. It might be something that a county government wants to do. It might be a mission-critical mobile application for your staff who are out there doing something. I don't care. And then look at your options. Look at the different providers that are providing the infrastructure. Look at these things, and just do it like you would any standard IT project. Take it, do the costing. Look at your ROI. Look at your TCO over time. We recommend a 3-year lifespan for the effort minimum, and really get the calculator out and look at the benefits and the uptime. You're going to have a learning curve experience, so don't have this be like in all things, take baby steps. But we see the most success in this kind of area by clearly defining a business process, get your organization behind it, and do the due diligence necessary to be successful. And you will learn massive amount of stuff, whether you have a consultant or not, in trying to get your application up and running, depending on what you do and what your logic is, and what kind of functions you're trying to solve. And that's what we've done. That's what we do for our clients, and it ends up being a fairly commonsensical approach to this new frontier.
Okay, thanks, Alex. So, Leslie, I think we're done and ready for questions if there are any.
Okay. So I think people are still gathering their questions. Great. So just so everybody knows, this is your chance to type in questions in the there's a little box, or you should see the word questions over in your panel, and if you click on the plus sign, you'll see that you can type your question in there. And once you send that, it'll come to me, and I can either forward it to our presenters or just read it for everybody.
Yeah, don't be shy. That was a lot of information, I think, in a fairly short time, and we'd love to be able to answer any questions that anybody has on this GoToWebinar.
And while we're waiting, I'll just remind everyone that this is being recorded, and it will be posted as a recorded webinar at our website, the VCGI website, and so you'll also be able to access this contact information again. Okay, my colleague Mike has a question. He asks about a recent VPR story detailing the pervasiveness of private sector companies specializing in online tracking. So within 8 minutes of being online, you're tracked by 34 different sources. So his question is, how can you protect your in-process work product from being tracked and misrepresented? Started out with a hard one.
Yeah, well, I'll go first. I would need more details and specifics. That's a pretty significant general question. I don't know if we're talking about tracking through cookies, if we're talking about these companies like Amazon or Microsoft or IBM or any others providing tracking and use rates. I'm not familiar with that level of compromise occurring on anything that we've done or anything we're looking at. Again, I personally need a little more detail, and if that questionnaire or that questioner would like to send something to us, we'd be happy to try to get into more detail and more answer. Everything we've been doing is fairly open in terms of an application space, what we're hosting, how we're hosting it. There are obviously safeguards, big time, in terms of accessing server infrastructure on the major providers that we work with. And we haven't noticed any significant security compromises. But again, not to beg off the question too much, but I just need more detail to try to answer Mike's question. John, you probably know more or have a better idea than I.
I don't have a comment. I liked your response. Thanks, Alex.
And I'll just say that Mike followed up by just saying he does mean it as a broad security question, that it is just a general broad security question. That's something I think that probably everyone who's looking at the cloud is concerned with.
Yeah, okay, well, fair enough. So. And I mean, I appreciate that, Mike. And I would say that as Mike alluded to, or as John alluded to earlier on, security is serious. We do defense applications and mission-critical applications. You'll notice that a lot of those security things are being addressed by the majors in the sense that you're getting ITAR-compliant cloud offerings now. Eventually, you'll have notions, and already do, but they're not discussed very much, classified cloud. So with the network and with the exposure comes trade-offs. However, we as a relatively small, high-end consulting firm, in terms of our server architecture, we are under much more attack here and feel more vulnerable, per se, in terms of our provisioning than we do in working with some of the majors that we described. So it's real. It's going to happen. It's a new frontier of security and security-related protocols. And as we go more and more cloud, in terms of distributed architectures and data centers, I think you need to look at both cyber attack as well as physical infrastructure, as John alluded to, and it should be part of any IT plan or any GIS IT plan that any organization has, to be aware of it, ask the vendors, ask people to discuss it, so that you go in eyes wide open. In that sense, I think it's a great question, and this isn't solving security, but it is in some ways we're improving in certain areas, and I think also opening up a new frontier. It just keeps happening every generation of technology.
Yep. And Pam has a terminology question. She has an ArcGIS server and would like to move her ArcGIS server software and all of its applications to the cloud. Is this, and she's looking for which acronym applies here, is this SaaS or IaaS or something else?
Go ahead, John.
Right. So if she's going to move it to ArcGIS Online, that's let me just bring up the slide again. So it's definitely gets a little confusing depending on your perspective. So ArcGIS Online, if she's going to move her just author maps and create publish on ArcGIS Online, that's considered software as a service. If she's going to actually provision her own operating system in the cloud and maintain and administer her ArcGIS server instance similarly the way she does it on premise now, that would be considered infrastructure as a service. So those AMIs from Amazon, those are you're spinning up, it's just like you're remote connecting into your server and working on your server. Of course, ArcGIS Online, which is software as a service, is an application that a web application where you log on to and you have new tools provided by ESRI to help facilitate publishing, publishing, and creating applications.
Yeah, my feeling is this questionnaire, this person is definitely moving into the IaaS environment, infrastructure as a service, and that's the most robust, the most power, and the most work, if you will, in terms of deploying into a cloud architecture. Some make it easier right now than others. Generally, these are following market trends, and there's a lot of power. I would recommend that IBM blog that John referenced earlier on that other slide. Since these slides will be made available to folks through Leslie's organization, you should go take a look at that. If you have any questions, let us know. But I'm going to say you're a candidate for infrastructure as a service deployment architecture.
Okay. Any other questions out there? Oh, here's one. And Mike adds to that last discussion, is asking, is it IaaS, sorry, I have to get the acronym right, is it IaaS if you plan to manage your own ArcGIS server software, or would that be PaaS?
Platform as a service?
Yeah.
Yeah, I mean, I think that's debatable. I hear different interpretations. Infrastructure, in many ways, is really when you have a much more control, or you're getting as much control as possible, as John mentioned, as the operating system level. Some of these environments are dual boot, where you're really you can be in a Windows environment, a Linux environment, etc. You really are able to tweak and optimize storage, processing, your network connects, and so I think you can see both. If you're just really doing what Mike asked for originally, then yes, it's more platform as a service. If If you really want to go into the deeper level, then you're really managing infrastructure as more than you're managing your deployed platform. Remember, application on top of service. So usually what I see most of right now is platform as a service with application as a service on top. That's what we do a lot of. We build, manage, deploy an application, but we're leveraging platform as a service. I think, you know, again, we came up with these definitions, which are fairly standard, just to try to put some clarity on a lot of terminology that Mike is right to ask about. And I mean, I'm not suggesting that my answer is any better than anybody else's, but that would be my fastest answer to Mike.
Okay. Any more questions? Got a couple minutes left.
And I guess I would just say, well, there might be one more question coming in here before the end of the webinar. Don't forget that in many ways when you have major IT paradigm shifts, that there's a lot going on here. So you've got the convergence of the big data phenomenon. Pay attention to that. You've got analytics, which is becoming explosively hot. And then obviously this whole notion of a cloud, which has been building for the last 5 years. In many ways, I see this as a renaming of concepts and ideas and visions that many of us have had, many of the people on the call have had. We've migrated from the workstation and the the heavy-duty unit workstation to the desktop, to the mobile platform, to to the tablet, and so you sort of see this inverse as we swing back now, not just to server-side GIS with the mega trend going on there, but now it's entire data centers that are being made available as our infrastructure. So we're actually able to spend more time thinking about the business processes and the business logic and the algorithm development and what we want to deploy as an application. And we're seeing this becoming ultimately very, very distributed in in multi-billion-dollar architectures that we're getting on pennies on the dollar. This is fundamentally changing everything, but in many ways it was what the future of distributed geographic information systems forecast 15 years ago. When everything started to go server-centric, this was only a matter of time before this stuff was occurring, and I think it's fundamental. This and augmented reality are going to fundamentally change how we do geography in the future. Has been my big claim. Anyway.
Okay, Mike has one more question.
Right.
MaaS. How beta is this? Is it something you guys are racing out front with, or has it already gained a lot of practitioners? Just trying to get a sense of where it is on the evolutionary scale.
Yeah, I like Mike. Mike, good questions. On a 1 to 10, 10 being fully cooked and evolved and at some homeostasis, where we are and where our clients are with modeling as a service is probably a 3 or a 4. I would not say it's pie in the sky theoretical. It's happening. As many of you know, Esri and others have dabbled with the whole idea of exposing with Model Builder, modeling as a service also. NASA and a lot of federal agencies have been trying to go this way. So I would put it, frankly, at like a 3 or a 4, and it's going to probably become more exciting and more available all the time. And major players are starting to see this, and I would say it'd probably get more mature in the next year, year and a half. It would be my call. John?
I tend to agree. Yeah, Alex, I don't have anything to add to that. Good.
Okay. So, Mike, good questions. Very good stuff.
Yes, and thank you, Alex and John, for doing the webinar. And thanks to everybody for participating. As I said, we will be posting the recorded webinar at the VCGI website. If you go to, actually I'm going to change back to me for just a second. So if you go to VCGI website, community resources, events, and scroll down just a little bit, you will see where the event archive is listed and webinars are posted. So just want everyone to know they will be posted. Thank you very much for participating, and thank you, Alex and John.
Thank you very much, Leslie. Thank you. Thanks to the good questioners, and I would hope that everybody got something out of this. So let us know what you think so we can make it better in the future. And thank you for the opportunity, Leslie.
Thank you. Bye-bye.